Hello, one. So we have another AMC 10 problem. So this was number 19. So we are told the L of n is the least common multiple of all the integers from 1 through n inclusive. And then there is a unique h such that this fraction is equal to h over the sum of these fractions is equal to h over L of 17. And we want to find the remainder when h is divided by 17. The first things first, like we want to make sure to understand what's being asked, and also like we are asked to find the remainder, which is a good time to remember the modular arithmetic, because that's usually what we kind of deal with them. So we want to find the L of n first. Like you have all these like 17 fractions add up together, and then it can be written like a number h divided by the least common multiple of 1 through n. So because that's basically the definition of the L of n, L of 17. So if I want to just start with this, so we are gonna have L of 17 as the least common multiple of any integer between 1 all the way to the 17. That is what they define, how they define the L of n, okay? So it is not too challenging either, because you just need to know like how many like 2's that you have and any other prime as well. So when you look at the numbers 1 through 17, and you want to find the 2 that has like larger power, and that will be the number that you're going to take as a common multiple of the list. So 16 is the one that we can take, which is 2 to the 4th power, right? Any other like power of 2's will be smaller than that. So which is why when you have the least common multiple, that should be 2 to the 4th. And a similar approach with the other primes. So 3 squared is the largest I can have. So which is why my LCM should have 3 squared. And then next prime is 5, but there is only first power because 5 squared is larger than 17. And then we got 7, and then 11, 13, and 17. So this is my LCM of these 17 integers. Okay, so that's L of 17. But we want to know the h, and then as soon as we know the h, we're going to divide by 17. So maybe it's better to multiply both sides by L of 17. I'm going to do that. So if I multiply both sides by L of 17, okay, so the entire sum, I'm going to multiply L of 17, so I can cancel these guys. So the left side became L of 17 times 1 over 1, 1 over 2, 1 over 3, all the way to the 1 over 17. So I'm going to write 1 over 16 as well. And then this is equal to h. So when you remember, the L of 17 is the product of these numbers. And then if you multiply L of 17 by all of these fractions, so when you multiply the 1 over 1 by this, the product will have 17 as one of the numbers in that product. So that means this guy is a multiple of 7, because we are trying to divide by 17. So when you multiply L of 17 by 1, that's a multiple of 17. And the same goes with the second fraction, because whenever you multiply this guy by 1 over 2, so we have already 4 2's, one of those will cancel, but the remaining will be still multiple of 17 because it has 17 anyway. So any fraction except the last one in this sum, when you multiply by the L of 17, will be all actually multiple of 17. So only thing that will be the concerning is the last one, which is 1 over 17 times L of 17. So which is why we are going to end up getting like 0, 0, zeros all the way to the 0. And the last one will be 1 over 17, and this 17 will cancel. So we are going to end up having like 2 to the 4, 3 squared, 5, 7, 11, 13. And then this 17 is already gone because we multiply by that. Again, these are going to be 7 zeros whenever I divide this guy by 17, and then we just say this is like congruent to I'll say H mod 17. So basically, whenever I divide those numbers on the left by 17, so I will see a one of these numbers multiple 17, which means the remainder will be zeros. And now we are saying they are congruent to 0 mod 17, except the last number. So now we want to say what this number is actually will give us a remainder when you divide by 17. You can go ahead and multiply and kind of divide by 17 to get H. That's going to be not challenging. But instead, maybe we can try some other ways. So like, this is 16, which is one lower than this. So when we use the congruency statements, we can just add any multiple of 17 or subtract any multiple of 17. So if I subtract 17 from 16, so this is congruent to just -1 because it's good to work with some smaller number, and then times 9. And then I can say, we have 5 times 17, so I can say this is 35, right? So 35 is 34 plus 1, so which means this is gonna give us a remainder of 1 when you divide by 17. So now we have 13 times 11, so I can just go ahead and multiply those as well. So if I want to, which is gonna give us some smaller values as well. So that will be 143. Maybe I can just, actually, I'm not going to multiply. I'm going to use the power of the negatives as well. So this is 6 lesser than 17, right? So I'm going to say, if you subtract 17 from this, so you will get -6. So that's congruent to 11. And the same thing with this, that's going to be 4 lesser. So that should be -4. So the goal is just to make the numbers as small as possible so we can multiply easily. So now we have 4 times 6, that's 24, right? That's 24, but that's going to be positive, which is good as well. And then this is going to be -9 and negative. So you multiply, you got actually positive number, right? So this is 24. So if you subtract 17 from 24, so we do get a positive 7, which means this guy is congruent to 7. If you multiply this by -9, so you got -63. And if you just add a multiple of 17 until you get this positive number, so which is if you multiply this by 4, so that's 68. If you add that to this -63, so we just get 5. So meaning that this is congruent to H mod 17. And this is our remainder, so that's the choice C. So it is not too challenging problem. It was maybe a bit hard to understand, but when you kind of come up with the LCM, so and then try to kind of get what you want alone, so that was kind of helpful. So anyway, so I hope that was clear. I'll see you in the next video.